Hey there, science fans! Welcome back to another exciting episode where we explore the wonders of the world around us. Today, we're diving into the fascinating world of forces and how they affect the structures we build. Have you ever wondered how those massive skyscrapers stay upright or how bridges can support so much weight? From towering skyscrapers to sturdy bridges, understanding forces is key to making sure everything stays put. These structures are marvels of modern engineering, and they owe their stability to the careful consideration of various forces. In the realm of civil engineering, forces are like invisible superheroes and villains constantly pushing and pulling on our buildings. These forces can be both beneficial and detrimental, and it's the job of engineers to harness the good and mitigate the bad. We call these pushes and pulls loads. Loads come in many forms, and understanding them is crucial for the safety and longevity of any structure. Loads are what we get when gravity, wind, or even people put stress on a structure. Gravity is a constant force that pulls everything towards the earth, while wind can exert pressure in various directions. Even the weight of people and furniture inside a building contributes to the overall load. Think of it like building a sandcastle on the beach. The principles are surprisingly similar. The weight of the sand, the waves crashing against it, and even a curious seagull landing on top, those are all forces at play. Each of these elements can affect the stability of your sandcastle, just like how different forces impact real-world structures. Civil engineers spend their days figuring out these forces and how to design buildings and bridges that can handle them. They use advanced computer models and simulations to predict how structures will behave under various conditions. It's like a giant puzzle, but instead of pieces, they use math, physics, and a whole lot of creativity. Every calculation, every blueprint, and every design decision is made with these forces in mind, ensuring that our buildings and bridges are safe and reliable. Now let's talk about different types of loads. Just like there are different ways to push a swing, forces can act on a structure in various ways. We can break down loads into three main types: point loads, distributed loads, and applied moments. Each of these acts differently and creates unique challenges for engineers. Understanding these different types of loads is like knowing the difference between a gentle breeze and a hurricane. Both involve wind, but their effects are vastly different. By understanding the specific types of loads acting on a structure, engineers can choose the right materials and design the right shapes to keep everything safe and sound. Imagine pushing down on one end of a seesaw with your finger. That's a point load. It's a force concentrated at a single point, like a person standing on a bridge or a heavy lamp hanging from the ceiling. Point loads create a lot of pressure in a small area. That's why you need strong supports like the legs of a chair or the pillars of a bridge to handle them. Think about a high diver standing at the edge of a diving board. That's a point load. Engineers carefully calculate these point loads to make sure the structure can handle the stress without buckling or breaking. Unlike a point load, a distributed load spreads out over a wider area. Imagine a pile of snow covering a roof or a bookshelf full of heavy books. That weight is spread out, making it a distributed load. Distributed loads are like spreading butter on toast. The weight is spread out so it's less concentrated in any one spot. This makes them easier for structures to handle than point loads, but they still need to be accounted for. Engineers use math to figure out how much weight a structure can handle before it starts to sag or bend too much. Section 5. Applied moments. Twist and shout. Now imagine trying to unscrew a really tight jar lid. You're applying a moment. A moment is a force that tries to make something twist or rotate. In civil engineering, moments are important because they can cause structures to bend or even break. Think about a flagpole swaying in the wind. The wind creates a moment that tries to bend the pole. Engineers design structures to resist these twisting forces. They might use stronger materials or add supports to prevent too much bending or twisting. Section 6. Beams, the backbone of structures. Beams are like the unsung heroes of the structural world. They quietly do their job, often hidden from view, but their importance cannot be overstated. Without beams, many of the structures we take for granted simply wouldn't stand. They are the horizontal structural elements that resist loads applied laterally to their axis. This means they take on the weight and forces that push down on them, and transfer these forces to the vertical supports like columns or walls. In simpler terms, beams are designed to carry loads and distribute them to the supports. This is crucial in ensuring that the structure remains stable and safe for use. Think of a simple wooden plank placed across two bricks. That's a basic beam. It might seem simple, but this basic principle is applied in complex ways in modern construction. Beams are everywhere, from the floors of our homes to the decks of bridges. They form the skeleton of buildings, bridges, and many other structures, providing the necessary support to keep everything in place. They come in all shapes and sizes, and they can be made from a variety of materials like wood, steel, and concrete. Each material has its own advantages and is chosen based on the specific needs of the project. Engineers use their knowledge of forces and loads to design beams that are strong enough to support the weight and other forces they'll encounter. This involves complex calculations and often the use of computer simulations to ensure accuracy. They also have to make sure the beams don't bend or deflect too much, which could lead to cracks or instability. Regular inspections and maintenance are crucial to ensure the longevity and safety of the structures. From ancient times to modern day, beams have been a fundamental part of construction. Whether in historical buildings with wooden beams or modern skyscrapers with steel and concrete, their role remains vital. The next time you walk into a building or cross a bridge, take a moment to appreciate the beams that make it all possible. They are truly the backbone of structures, working tirelessly to keep everything standing strong. Section 7. Equilibrium, finding the balance. We've talked about forces and loads, but what keeps a structure from collapsing under all that pressure? The answer is equilibrium. Equilibrium is like finding the perfect balance point. Imagine a seesaw again. If two people of equal weight sit on opposite ends, the seesaw will be perfectly balanced. That's equilibrium. When a structure is in equilibrium, it means that all the forces acting on it are balanced, and it's not moving or rotating. In civil engineering, achieving equilibrium is crucial. It ensures that buildings and bridges can stand strong and withstand the forces they experience every day. Section 8. Conditions of equilibrium, the rules of the game. To determine if a structure is in equilibrium, engineers use two main conditions. The sum of all forces and the sum of all moments must be zero. These principles are fundamental in ensuring that buildings, bridges, and other structures remain stable and safe under various loads and conditions. First, the sum of all forces must be zero. This is known as the equilibrium of forces. It means that all the forces acting on a structure must cancel each other out. If there is an imbalance, the structure will move or collapse. This means that all the upward forces must be balanced by downward forces, and all the forces pushing to the left must be balanced by forces pushing to the right. Imagine a beam being supported at both ends. The weight of the beam and any additional loads must be counteracted by the support forces to keep it in place. It's like a tug of war where both sides are pulling with equal strength. If one side pulls harder, the balance is lost, and the rope moves in that direction. Similarly, in a structure, if the forces are not balanced, it will move or deform. Engineers use various tools and techniques to measure and ensure that the forces are balanced. They analyze the loads, calculate the forces, and design the structure to withstand these forces without moving. Second, the sum of all moments must be zero. This is known as the equilibrium of moments. Moments are the twisting forces that cause rotation. For a structure to be in equilibrium, the clockwise moments must be balanced by the counterclockwise moments. This means that all the twisting forces trying to rotate the structure clockwise must be balanced by forces trying to rotate it counterclockwise. Think about tightening a bolt. You apply a moment in one direction, and then another moment in the opposite direction to tighten it properly. Engineers use moments to analyze the rotational stability of structures. They calculate the moments caused by various loads and design the structure to resist these moments. This ensures that the structure does not rotate or twist under load. By applying these two conditions, engineers can ensure that their designs are stable and safe. They use advanced software and tools to model the forces and moments, simulate different scenarios, and optimize the design for maximum stability. The rules of the game are simple but crucial. By understanding and applying the conditions of equilibrium, engineers can create structures that stand the test of time, withstand natural forces, and provide safety and reliability for their users. Section 9. Conclusion: building a stronger future. So there you have it. Forces and equilibrium are fundamental concepts in civil engineering. They help us understand how structures behave under load and allow us to design buildings and bridges that are safe, strong, and can stand the test of time. By carefully considering the types of loads, designing appropriate beams, and ensuring equilibrium, Engineers play a vital role in shaping our world and ensuring a stronger future for everyone. Keep those brains curious and remember there's always more to discover in the world of science.